Hello, and welcome to this series of tutorial videos for MassAI. My name is Morten Rasmussen, and I'm the developer of MassAI. In this episode, we will take a look at the results generated from last episode's search. In the last episode, we did a quick and dirty search against an MGF file and with the entire human proteome as a search space. Like I said, the search was very simple. There's so many parameters that we can change, such as the number of miscleavages. We can fiddle about with the mass tolerances, the number of modifications accepted per peptide, and so forth and so on. What we did in this was just very basic, using the default values that MassAI suggests, and normally this gives pretty good results. What we want to know in this case is what proteins this sample contains. Once our search has concluded, it will pop up a window saying search is done. We'll close the window and MassAI opens up 3 new windows, which is what you see right here. The first window simply shows us the proteins identified in the sample. In this case, the human protein calreticulin is the top scorer with 11,000. Below it we have 3 runner-ups, which is calmodulin, which is commonly found along with calreticulin. And below this, we have the very low scoring PET proteins, which are probably not present in sample, but so they're all showed in pink. So we'll stick with calreticulin. Behind this window, we will find for every protein the sequence coverage. The identified peptides are shown in green. The ones in black have not been observed in this particular search. As you can see, this is the leading sequence. This is generally not in the actual active protein. It makes good sense that it hasn't been observed. Down here, we see the sequence coverage, 77%, which is pretty good for one particular file. If we close this, the third window shows us the result list scan by scan. We can sort any other columns up here by clicking on the top bar here. If you click it once, it'll sort it by ascending order. Click it twice, it'll sort everything by descending order. You can hold down the control key and click another column and it will sort this secondly. You can have an entire row of sorting in sequence. In this case, we'll just go by the score. Now the top score is 37. You click it and it opens up the annotated scan. This is not a particularly interesting scan, no, not little fragments. Go down a bit. Now this is much more interesting because we get not only the B and Y ion series in pink. I don't know if you can see it in this. We just zoom in. You can see the isotopes highlighted in pink and the fragment ion in blue. So Y ions always annotated in blue, B ions always annotated in green. We have losses such as loss of water, loss of ammonia. These are all annotated in purple. If it grows confusing with all the information, down here we can switch things on and off, such as the isotopes. They have done their job. We can also switch on and off the internal fragmentations, which do happen. We have a few of them here, on and off. We can turn off the losses if we want to examine just the B and Y series, and so forth. Lots to play around with. Down here, we have the annotated sequence with the observed Y ions in blue and the observed B ions in green. Hover your mouse button over any of the fragment ions, like here, for instance, between the lysine and the proline, and you'll notice that on the scan that it annotates with peaks pointing downwards, where we expect to find this particular peak at the different charge stages. You can see here Y7 is the most intense ion, just neighboring with Y2, which is this one over here. Go back to Y7, and we can see in blue here the singular charged species is what we observe. It's in blue. To the I can't really move my mouse button here, but over here to the left of it we'll find the Y7 ion with the doublet charged. It's also annotated in blue, which means that we have observed it. To the left of it we have the Y7 ion in the triplet charged, but this one is in red, which means that it has not been observed in this particular scan. Makes good sense. The scan is a triplet charged. You can just use your mouse up and down keys to go through the different scans. have the metadata, which just move this aside, and the information you get in this particular table is, well, you get a lot of information, and you can just browse through it. So many columns, each containing kind of information on each scan and its observation, such as the peptides, of course, important, the protein where it comes from, the mass error in ppms and in Dalton, the charge of precursor, retention time, and so on and so on. Loads to play around with. In the tab sheet next to the non-modified peptide, we've defined all the observations of modified peptide. In this case, we only have one modification, which is carbamidinomethyl and oxidized methionines. I have chosen to present these in a different table from the non-modified because sometimes you want to pay a special attention to the modifications if we're looking for phosphorylations or glycosylations or cross-linked dead ends and so forth. It's practical to have them in a separate table. But the same thing goes. You can just click on them, use your up and down keys to get through all the scans containing the modifications. Next to this tab, we have the cross-link peptides. In this case, we did not search for cross-link, so this is blank. The next one shows us the results below the score cutoff. Now, we've only shown the results with a specific cutoff. In this case, it's a cutoff of 10 in the MassAI score. Everything else is not displayed in the non-modified peptides or modified peptides, but they're still in there. And sometimes they do contain valuable information. Just sort it. As you can see, what is not displayed is kind of messy and not very trustworthy. But in MassAI, we always take care to present all the evidence that we have, all the observations that we have. Then it could be up to you to dig into this to see if there's anything of value in here. I'm going to leave the rest of the ways that we can present the results to a later video because this is just the second video in a row. If you enjoyed this video, be sure to click the like button. And if you want to stay updated with my series of videos, be sure to click the subscribe button. If you have any requests for features in my site that you'd like to see a video being made around, do leave a comment in the field below. I'm your host, Morten Rasmussen, and until next time, happy searching.